Okay. We are ready for our next presentation here. It's Thomas, also known as Tykling, one of the organizers, who is going to talk about his very fantastic work about running uncensored DNS servers here in Denmark. Let's give Thomas a big hand.
Thank you. Okay. My name is Thomas. I'm 30-something years old, and I work for an ISP, where part of my work is to manage the censored DNS servers. And since I started that work, I've been almost since then I've been running uncensored DNS servers privately because DNS censorship just doesn't make sense for a lot of reasons that I will be covering today. I'm a co-organizer and I run my stuff on FreeBSD, and you've probably all met me during the week. So, okay. Uncensored DNS or censorfri DNS in Danish is pretty simple. It's just a couple of name servers that respond to questions about IP addresses and all other DNS information. We have a whole range of different content that is censored on the official ISP DNS servers in Denmark. And the servers that I run are simply unmodified version of the DNS. There's no filtering as it should be. There's two different servers like you usually get with DNS. One is Anycast, so it is in multiple locations with the same IP, kind of like Google and OpenDNS does. And the other one has redundancy as well, so there's more than two servers, but two IPs. They're used quite a bit in Denmark, but also in various countries that have various forms of DNS censorship, or by users that just dislikes the idea of handing over all their DNS lookups to Google and doesn't want to have logging and censorship in their DNS service. Typically, I see a surge of users from the countries like the countries in the news. So when Turkey started censoring Twitter a few years ago, I saw a big rise in the number of users from Turkey. I have a lot of users from China, which of course has massive internet censorship. And during the Arab Spring, different countries started appearing both on the web servers, but mostly on the DNS servers, which is nice. I mean, I can sit comfortably at home, run a couple of DNS servers. It's not really that complicated, and help people all around the world avoid censorship, and it's really nice. So I started running this in October 2009, so a few years after I started managing the ISP DNS servers, mostly because friends and other people kept asking me what to use instead of the ISP's DNS servers, because the Pirate Bay had been blocked and different other things were being blocked, so people were looking for alternatives. At the time, Google DNS did not exist, but I wouldn't have felt comfortable recommending them since they already know enough about us without having all our DNS lookups. So do not use Google's DNS servers. OpenDNS did the thing with the NX domain redirection, where if you typo a domain name, they redirect you. Instead of returning an NX domain error in the DNS response, as they should, they return an actual response pointing to an IP address which belongs to them, which shows ads and does a search and say, did you maybe mean something? Which is, of course, a violation of every DNS IFC and a horrible idea. So I didn't want to recommend them either. Also, DNS is like one of the most basic things controlling security on the internet. If DNS can't be trusted, then most other things like our CA system and all that is all based initially on DNS and email and everything. everything is based on DNS. So you don't just put 4.1.1.2 or whatever they're called, because you heard somewhere that if you send them a DNS query, you get an answer back. It's a matter of trust. You need to find a DNS provider, like you choose other providers. You find somebody you trust. And so all this led to me starting these DNS servers. I started them by myself, and I'm running them unfunded, but I'm getting help from friends with configuration and network and stuff. Okay, so I'll cover how DNS censorship works in Denmark. It's pretty similar in most countries, but of course I have the most experience and knowledge about the Danish DNS censorship. We have the questionable honor of being like a model country for internet censorship. So a lot of regimes that we typically do not wish to compare ourselves with have copied our model of DNS censorship and are now using it in various places to censor Facebook or Twitter and whatever, which is of course not something you want to be a model for. Since 2005, we've had DNS censorship in Denmark. It all started out, as these things often do, with Think of the Children. We have a system in which the Save the Children Denmark and the police cooperate to maintain a list of domains believed to contain images, websites depicting child abuse in various forms. It's automatically updated, and the ISPs are strongly encouraged, if not forced, to include this list on their name servers, so they cannot be resolved. This was 2005, and back then people were warning that this could be a slippery slope, and it might be used to censor other things that are maybe not as serious as child abuse. And the next year and the following years, lots of stuff was added that has nothing to do with child abuse, even though the initial promise was, of course, that this would never happen. This is one of the best examples of the slippery slope censorship argument that you could possibly ask for. I mean, there hasn't been a year since where a new thing hasn't been added to the censorship list. All of MP3 and the Pirate Bay are, of course, copyright-related censorships. And we also, in 2011, got some legislation saying that online pharmaceutical vendors that are unlicensed and targeting Danish customers to sell like fitness drugs for working out and stuff like that, and Viagra and other things that you might not want to talk to your doctor about, were all added to the censorship lists. And in 2012, gambling sites which do not pay a license to the Danish tax authorities were added as well, many of them. And Grooveshark, if you remember that, and a lot of other things. And lately, from 2014, the Danish authorities have been seizing .dk domains at the registry instead of censoring them on the ISP servers when the domains are under the .dk TLD. And there's like 40 or 50 different domains. It's typically typo squatting domains or sites that are selling copy merchandise like fake Nike shoes or whatever. And it's a new policy that they go to the registry and seize the domain, and it's a weird legal trick where they say they seize the domain as evidence, which anybody who knows anything about how DNS works knows that it makes no sense to seize a domain as evidence, because it's not a thing you can see. So they pointed at some ugly page saying this domain has been seized by the police for the period of the trial, and when they get the judge's word that it's illegal, then the domain is cancelled, I guess. So yeah, so they actively take domains away from people and point them to the domain servers. Okay, so we have different types of censorship, like I said, but only the child abuse related blockings are automated in this way. The rest is handled on a case-by-case manually by adding the domains to zone files. But we have an automated system for the child abuse list because it's updated every day or often. So the ISP sends an SSH public key to the police, and they add it to their server, which hosts the list. And the ISP uses a cron job to regularly fetch the list with SCP and to format it into something that fits into the name server. And then the name server starts believing that it is authoritative for those domains, meaning that it will not do the regular recursion that name servers should do. It'll answer with an IP address of a web server that the ISP has to run, which says, like, stop, you are not allowed to go to this domain, it contains illegal content. And the web server that hosts this stop page logs, like all web servers do, the accesses, and the log file is scrambled, the IP address is scrambled, and it's then sent to the police every day. They want this data so they can know if they have 10,000 hits on the stop page, if it's one guy doing 10,000 clicks or if it's 10,000 guys doing one click. But the ISPs have demanded that they don't hand over the personal information, so the IPs are scrambled. But when I took over managing this system in 27, the way of scrambling the IPs was to MD5 them with no salt. And most people here knows that it would be a small feat to make a rainbow table of all IPv4 addresses. It would take a day on a laptop today, which means that, of course, they were not anonymous at all, so the police would be, if they wanted to, able to identify who were accessing the stop page. So this is the system. It's been in place for over 10 years now, and is by the police and Save the Children Denmark proclaimed to be a great success, which is a blatant lie, and it's self-serving for various reasons. I don't have time to go into the details, but suffice to say that we, from the government in Denmark and from the EU, give funding, which is millions every year, to Save the Children Denmark to operate the hotline where people can report the domains. And this hotline then forwards the domains to the police, and the police add it to the blocking list. And if you're going to ask, like once a year, there's a story in the news where Save the Children and the police say that it's a great success and we should keep the censorship going. But if you're going to ask if something is a good idea, then you shouldn't ask the people who are getting paid if it's a good idea to keep doing it, because obviously they're not going to vote to remove their own funding. It would be insane. So even though they have good intentions, I believe that they're being dishonest about the efficiency of this to keep their funding and to symbolically look like they are doing something, even though they are actually doing more harm than good, which I will cover now. Okay, there's a whole bunch of issues doing censorship in the DNS. Some of them relate to all kinds of censorship. Some of them are only relevant for when you are censoring child abuse content. But I'll go through them in no particular order. First of all, we have this blogging page saying if you go to a web browser and enter one of the blocked domains, it says that you're not allowed to go to it. But that's only for HTTP, and as people here well know, the internet is more than a web browser. Politicians may not know this, but it is. If, for example, you send an email to one of the blocked domains, it will still resolve in the web server, in the DNS server, to the IP of the web blogging server, which doesn't run a mail service, but if they wanted to, they could intercept all the mail for these domains. But as it is, the port 25 isn't even open, so it would sit there. Your sending mail server would sit there and chew on it for the 4 days, specified in the SMTP RFCs, and then you'd get a bounce, which is of course stupid. It is also a really big problem that the blocking system we have is like a single point of failure introduced into an otherwise redundant system. DNS is one of the only things we have where it is explicitly specified in the RFCs everywhere that you need to have two at least servers, and they need to be on separate subnets and all this. All this is of course because DNS is so important that we don't go away. That we don't want it to be down ever. So when you do a system like this that automatically updates a list of blocked domains and then something goes wrong, then you introduce a single point of failure into the system. And this happened in 2012 when a few ISPs, among them was the one I was working for, got hit with an update of the list, which happens periodically, like I said. And like our customer service was bombarded with calls. Ironically, Save the Children Denmark was one of our customers, and they also called to say that no matter what page they were accessing, they got the stop you're accessing child porn warning page, because the police accidentally sent us an update with like 8,000 domains, which like google.com and YouTube and Facebook among them. And then all those domains were blocked and people were seeing the stop child abuse thing page. So this is, of course, was a disaster and should have ended the system immediately, but it didn't. And I was pretty proud to see a blog on the Washington Post where Denmark and China had problem with their web censorship this week or something like that. Always nice to be compared with some of the worst totalitarian societies in the world. Okay. So, when you block child abuse content like we do in the DNS, these DNS servers are publicly available, of course, to anybody who's a customer with the ISP, with any ISP in Denmark. The problem is that we all agree that the people who run child abuse content sites are like some of the most despicable people we can think of. But if you block in the DNS like we do, you actually run a pretty well-funded early warning system for these criminals. So you're actually actively helping them, because as soon as you add one of the domains to the blocking list, it'll cost him 20 kroner a month to buy a VPS somewhere in Denmark so he can do a lookup on a Danish server. And when he sees that his domain is suddenly not resolving to the proper IP anymore, but to some IP belonging to the ISP and resolving to the blocking page, then of course he can change the name of his site. He knows he's been detected by the authorities, and he can run his service, continue his service under a different name. So what we're doing is not only ineffective for anybody who actually wants to access this stuff, they will get it anyway through Tor or in a million other ways. But we're actively helping the people who are hosting this content by warning them when we found them, which is of course absolutely stupid. More issues. So DNS censorship conceals problems without actually removing them. It's like pulling the curtains to something bad going on. The correct course of action when you find something like this is, of course, not to add it to a censorship list, but to get the content taken offline. And don't believe for a second the stories that we operate this censorship because it's impossible to get the content away. It absolutely is possible. 3 or 4 years ago, a German got a leak of the list of blocked domains. Somebody, I don't know who, leaked the list to him, and he analyzed it, and he found that out of about 2,000 domains, like 90% of them were either dead or were like parking pages, like this domain is for sale, or this page is hosted by something without actual content on them. A few were regular porn sites, and I think 3 sites he found in the whole list that actually had illegal content. And he, as a civilian with no authority at all, contacted the hosting providers and had all 3 pages taken down in less than 24 hours. These were domains that had been on the Danish blogging list for years, with nothing being done about it. So it's not only it is actively harming, and it is keeping the content online for much longer than if we actively tried to take it offline, which pisses me off. Okay, so DNS censorship is also incompatible with DNSSEC. You can't tell the difference between a resolver lying to you for censorship reasons, or if it's a hacker spoofing the signatures will not match the ones. We've implemented something that actively harms security, and which is, of course, in this state, never a good idea. We also block, when we censor on a domain level, we block everything on the domain, even though maybe only one picture is illegal on the website. So we've had image sharing sites where a load of legal content was taken offline, which is, of course, never a good thing. And like I started out by saying, it tends to be a slippery slope when you do censorship, because you tend to allow the censorship for smaller infractions, and finally it becomes like this Swiss Army knife. So if anything is wrong or unpleasant on the internet, of course, at the moment we're talking about Islamic extremist websites, content like encouraging terror and stuff. They're talking about they want to add that to the list as well now, and of course, blogging stuff for political reasons is like something we should be done with as a society long ago. So stop believing that hiding a problem will somehow help to solve it. It is pointless, it is stupid, it is actively helping the people we want to stop, and it is actively harming. If we believe that every viewing of a video or an image of a child being hurt is another offense, then of course keeping the content online for 1 second longer than it needs to be is, of course, in itself a crime. So we should stop this. Which brings me to something that I've been doing this presentation at various conferences, like at RIPE and at DKNOC and various places where there's less of a hacker culture than here. And I've been saying this, I don't think it's as relevant to say it here because all you people are painfully aware of this, but there is a basic conflict between security and freedom on some level, and there always will be. There's no question that my name service can be used to resolve domain names that has illegal content. Of course they can. So can Krams's access points and switches here be used, and the roads can be used to drive around in doing so. Of course they can. There's no question about that. When you run open resolvers, they can also be used in amplification attacks, which has happened and is continuing to happen. But stuff like Tor and Bitcoin and most of the other things that people here work with from day to day are dual-edged like that. They greatly enhance the freedom and our ability to be free online, but they also have potential for abuse, and we need to accept this, and we need to be aware of it when we are discussing these things. That there is a conflict, and we can never have both. But you already knew that, of course. I always like it when I'm done with the political part of the presentation and get to the technical content. Okay, so I got some IP space from RIPE just before we ran out, which was really lucky. I have a /24 v4 range and a /48 v6 range and an AS number, which means I can do Anycast for one of the servers. Anycast is a method where you in BGP announce the same IP address from from several locations, so I can have a server in Copenhagen and one in Amsterdam and one in New York, which which all respond to the same IP. And depending on where you are, BGP-wise, on the network-wise, on the internet, you would hit the server that is routing-wise closest to you, which is very often the geographically closest as well, because the internet is so interconnected these days. You all know this from Netflix and Google, and everybody is doing Anycast, which means that if you access like a Netflix server or a Google server, you will get one typically in your own country. In most countries, they have caches these days, but you are still accessing the same IP addresses and the same domain names. They just do magic in BGP to make you go to the closest server. It was really nice getting these ranges, and Kamse down here helped get it, and it is awesome because it is a permanent assignment. I can keep these IPs for forever, and which means that I don't have to change even if I move providers, and I can do much better redundancy, and I can get better performance, because if I put a server in Asia, then my Chinese users will hit that one because they have latency issues, of course, because they live in China and I live in Denmark, or the servers live in Denmark. It's running, the Anycast service is running. We have a few nodes in Denmark, but of course I always need more nodes to make the Anycast service more responsive and more redundant, more stable. So if anybody works for a provider which can, it doesn't need to be a powerful machine, but preferably a FreeBSD box, 4 gigs of RAM and 20 gigs of disk, and a public v4 and v6 address, and importantly, the ability to announce the prefixes, my IP ranges into the BGP. So if anybody works for somebody who can help with this, please let me know. Okay. So I was talking a bit about DNS amplification, and this is definitely a problem with open resolvers, and basically it's discouraged to run open resolvers these days because of the potential for abuse. But like I said, we have to accept some abuse if we want to provide services which enhance the freedom and security online for everybody. And DNS dampening can help a lot with the DNS amplification. It is inspired by BGP dampening, which is a system where if you send too many BGP updates too quickly, you get like silenced for a bit, so you get ignored kind of. So even if you send more stuff, it won't be processed. And DNS dampening is kind of like that. It's rate limiting, but not like the typical kind where you set a firm limit like this IP can do this many lookups per X seconds or whatever. That won't really work for DNS because I have some ISPs using my service, small ISPs, which mean they have like maybe a few thousand users behind one IP. So if I set a limit, then I would have to set it so high that I can have 2,000 users behind one IP, and which would make it pointless because then I would never catch the actual abusers. So like stupid plain old rate limiting is not for DNS. Which is why it's really weird why ISC went with the response rate limiting they built into bind, but I'll get back to that. DNS dampening is rate limiting based on a scoring system where the size of the packets, the difference in size from the incoming query to the outgoing response is used to calculate a score for each query and then add it up. And if you get over some amount of points because you've made a lot of small queries with large responses over a short time, then you get blocked, and after a while you get unblocked again. So it's like it's like a scoring system. If you repeat the same query over and over and don't like alternate the queries, you get penalized way more than if you have a more regular pattern, which like if you're surfing, you still do a lot of lookups, but you don't do the same lookup again and again and again. Any operating system resolver has its own local caches, so you wouldn't never see isc.org any query 100 times in a row from the same IP. That's so obviously abuse, so that get penalized heavier. It works really, really, really well. It cut my number of queries, and I have removed 90% of the queries, which was just abuse. a few years back when I started using this. It is amazingly effective, and I don't understand why it isn't built into every single DNS server software on the planet. It was the patch set for bind that I'm using is developed by a German guy called Lutz Donnerhage. He isn't maintaining it anymore, so at the moment I'm having to hand maintain a patch set for bind, which is a pretty fast-moving target and a pretty large and a pretty idiotic code base in a pretty idiotic language. So I want to separate this out of bind. I want a separate piece of software to sit in front of any DNS server, so I can more freely choose which DNS server software I want to use, and just have this proxy sitting in front, which does the scoring of the clients and the penalizing, so it doesn't forward the queries to the backend DNS server if a client should be silenced because it's doing too many lookups. Also, you can use TCP fallback in DNS. Of course, if you don't get a response on UDP, your resolver retries with TCP, because of historically Cisco has been pretty retarded about this. They've been blocking packets which is more than 512 bytes, which means you can send a question where you never see the response because they for some reason believe that a DNS response would never be over 512 bytes, which means that we build in a fallback in the system where you retry with TCP, which means you can get bigger packets through. But TCP, I mean, this spoofed, these amplification attacks is of course spoofed traffic coming from, looking like they are coming from the IPs that are actually being attacked. So the IPs I see on my server is a spoofed sending address. But if I block somebody for doing too many queries and I then get a connection over TCP from the same IP, then I know it's not spoof traffic I'm seeing, because you can't possibly do a TCP connection from a spoof because you need to do the three-way handshake. So you can use the TCP fallback in DNS is really important in this regard, because you can use that to know that you have false positive in your dampening, and then whitelist the IP or at least reset its scores or something. So I'm getting help to build an Erlang-based proxy for this by Alex, and one of the things we're looking to do is to use this TCP fallback to know when a client is not actually. I mean, sometimes I'm doing something in the DNS which causes myself to get blocked because I'm checking some DNSSEC stuff, and DNSSEC does mean larger responses, of course, because you need the signatures to fit in. And I get myself blocked, which is really stupid. But if only I had a system where, because my machine, when it doesn't get a response, will, without me even knowing it, try TCP fallback. So it would be very nice to have that as well. It looks like this. I don't know if you can see it, but it's just the same client doing a query for the root, for dot, and any query. So it wants the whole set of records the server knows. And it's appearing to come from some IP. And it does the exact same lookup a bunch of times, like 10, 20 times in a second. And then it waits 10 seconds, and then it does the same query again. And it starts out by having 0 points, and then goes to 110, 311, 612, 1,000, 1,500, 2,000, and pretty soon it reaches 25,000, and then its dampening is activated, and then I don't see anything from it for 10, 15 minutes or something, and then the dampening system slowly trickles the scores down, and when it gets below 25,000, it'll get responses again. But if the first thing it does is to make one of these high-scoring, high-penalized queries, it'll quickly go above 25,000 again. So I'll only see 1 or 2 packets, which in a DDoS is nothing. I mean, it's effectively removed the problem of these repeat queries. There are variations which this is less effective against, but if I can remove 90% of the abuse pretty easily, it would be stupid not to do it just because it isn't 100% effective. This also goes in much of the rest of computer security as well. Okay, so I have the DNS dampening code on GitHub, and like I'm saying, I'm working to replace it Not just because it's a hassle keeping the patch set maintained, but I would like to have the option at least to move away from bind. The other servers are maturing so much faster, or so fast, and they have really neat features, Unbound and the others. So, but at the moment I'm forced to stay on bind, which is annoying. So I'm very much looking forward to the proxy work. Okay, so I have a few statistics for dampening and a few statistics for the rest of the servers. About 4,000 times in 24 hours I had dampening was activated for an IP, and those 4,000 times was 1,763 unique IP addresses. So they come back. I mean, this is all botnets, of course, doing this, and the code might be aware of what I'm doing and trying to counteract. But if it gets blocked and stops seeing responses, it backs off for a while, and then maybe it comes back an hour later or 2 hours later, and then gets blocked again. So about 2 dampening events per IP per 24 hours or something like that on average. But some of them are much more aggressive. The top one was put in dampening 119 times in 24 hours, and some of these, like we know from the other talks, and generally some botnets are way more sophisticated than others. Some code is way more intelligent than this. Some things are maybe just brute forcing, just stupidly sending endlessly and not checking whether the responses come in or not. So, and it varies a lot. This is just one random day, and the numbers are a bit old because, yeah. So, but there's absolutely no question that dampening works wonders for me, and it means that I don't have to feel as guilty about running an open resolver as I used to do, because they do get used to hammer people's servers and stuff, and of course I don't want to be a part of that. But I bet a lot of people in here run Tor relays, even though we know that a small part of the traffic that runs through Tor is illegal content and stuff we don't want to be identified with. But we accept this. Okay, so they see about 200, maybe up to 300 queries per second each server. The first one is a bit more busy because most of the OSs don't really balance that well across the configured resolvers. These numbers are without the dampening, with dampening enabled. So I'm not counting all the botnet traffic that's filtered out. It is the numbers are way higher when dampening is off. And when suddenly bind releases their bug number 10 million this year, and I'm for a while I have to like update bind right now, and then I have to pretty quickly get the patch set updated to whatever bind is doing now, and the period in between there, I see the bandwidth on my servers and everything go up because I have these small windows where I don't have the patch set added. So it'll be really good to get this problem solved. A little over 10,000 unique IP addresses in 24 hours, but I have no idea how many users. It is absolutely impossible to say, but I know a few small ISPs are using them. I know a dorm in China is using them over IPv6 because some guy there found some way to get through their firewall so he can get uncensored DNS lookups for the whole dorm over IPv6. So I really don't know how many users, but quite a few. This is in 24 hours, 10,600 unique IP addresses. This is not counting, some people enabled some pretty aggressive IPv6 privacy features where each lookup looks like it comes from a new /64 address and the /64 that's configured. So you configure your machine to do outbound translation of the source address, and one day I got up and I had like 30,000 new users since yesterday or something. Okay, something has to be wrong, and it was all from the same /64. So I'm counting in these numbers /64 as one IP, which also isn't correct, of course, because here, for example, we are all, I think, in the same /64. I don't know, but definitely you can easily have more users than one in the same /64. So I also have some query type distribution, but the data is a bit old. I wasn't able to get around to updating them, so I would expect I'll make the presentation available if you want to study the numbers. But I would expect the quad A lookups to have risen since this, and especially the DS lookups and the other DNS key and the RRSIG, the other DNSSEC related, because much more traffic is many more systems are DNSSEC aware now than just a few years ago. So there's one mail B lookup which predates MX, which I always find fascinating. I don't know what system out there is trying to deliver mail, trying to look up a mail B record, but something somewhere needs to be updated, that's for sure. Okay, I'm primarily included this to show the bottom number. This shows how many lookups was received. I don't actually know over how much time these numbers are for, but it's just the relationship between receiving 31.8 million IPv4 requests and 53,000 IPv6 requests, and then 24.5 million of them, that's the bottom number, are dropped due to dampening. So yeah, 25 million out of 31 million is botnet traffic and is filtered out. That's a large percentage. Okay. I switched to using Ansible to manage the servers a while ago, or am in the process of doing so. It is absolutely awesome. It makes it way easier to have a bunch of identically configured Anycast nodes, which is of course important if you're doing something like this, that the stuff is configured consistently and identically, and to make it easy to update stuff. And I haven't put the stuff on GitHub yet, but it will be at some point. And if you haven't used it and you have some systems to administer, I cannot recommend it higher. It is a very, very nice system. Actually, the whole Bornhack infrastructure was also built using Ansible, and all that stuff is public on our GitHub repository. So you can see how all the web servers and all that stuff has been built in the Ansible playbooks that we've published. Okay. There is a privacy issue and like a last mile issue in DNS, where we have DNSSEC now, which secures the path between the recursive resolver and the authoritative server. It authenticates it, but it does not encrypt it. And the last bit between my servers and the laptop or whatever is doing the lookup is unsigned. You can check the signature when you get it down, but typically in DNSSEC, the idea is that your recursive resolver does the signature checking for you and tells you whether it is validly signed or not. Your client doesn't actually check this. So the last bit is vulnerable both for privacy reasons, like everybody can see in clear text what you're doing, and it's also unauthenticated. So a while back, I started looking at how to solve this, and at that point, DNSCrypt was in a sad state. The client software was pretty horrible, and the server software didn't work at all, at least not for me. So after trying a bit and playing around with it, I decided to wait a few years and let it mature. And in the meantime, I did an OpenVPN project where I published some keys, credentials to log into an OpenVPN server I was running on the DNS server. It only permits traffic on TCP and UDP port 53, and so you basically dial in. Everybody uses the same key, and you configure the VPN endpoint IP as your DNS server, and it just tunnels it over OpenVPN. It's a pretty simple solution. It doesn't scale that well. I can't do 10,000 OpenVPN connections on a DNS server as easy as I can do 10,000 DNS server clients. But it works really well, and OpenVPN has clients for a lot of operating systems. So it's been a nice interim solution. It's still running, but probably not for long, because the alternatives are beginning to look much better. One of the alternatives is DNS crypt. I'm looking into it again. It has matured a lot since then. Both their software, their website, and the whole project seems considerably better now. They have support for a whole bunch of operating systems, which is awesome. And I will be doing a public test of this pretty soon. If it goes well, I will go put it into production on my servers. But I am actually even more excited about the new DNS over TLS RFC that came out. To me, it seems like a really, really good way to do this. We have, but you can read the RFC, it's not that long, but basically you establish a TLS connection on TCP port 853. It uses PKI. You can either use it's up to the client how to verify the key, of course, the public key, but it supports, which I think is important, like HTTP public key pinning. It supports pin sets, so you can publish somewhere out of band or somewhere that I could publish the fingerprints I'm using for my DNS servers, and I can publish an extra set. So if the first one gets compromised, I can switch to the second one, and people will still know how to. So it enables the client to validate the server, so you can't do man-in-the-middle stuff anymore. You can't do, like Telenor in Norway are actually intercepting port 53 traffic going to my DNS servers and redirecting it to their own not DNSSEC-enabled DNS servers. So people in Norway who are customers at Telenor who are actively trying to improve their security online by using a DNSSEC-enabled server are being redirected to a server with worse security. They're actively lying. They're redirecting transparently. So people think they're using uncensored DNS, but they're actually using another server. For that reason, I'm running a service called check.uncensoreddns.org, where you can dig a TXT record at that name, and it responds with a sentence saying, "Congratulations, you're using uncensored DNS," or "No, your DNS server IP is this." So you can use that to detect interception of your DNS traffic and see which resolver you're actually using. This can also actually be useful if you have a complicated set of forwarders. In companies where you have 8 Active Directory stuff configured, it can be hard to figure out where it actually exits. So one resolver is forwarding to another, which is forwarding to a third, and you can't really figure out where the hell it actually leaves and goes out to do the recursion to the authoritative servers. So you can use this to figure out where you're actually exiting the recursive DNS system. The code for this is public. It's a really small, very simple Python server that's running, and it's just responding with the IP of the client asking it, running a very simple authoritative DNS server. Okay, so back to DNS over TLS. It makes it possible it both secures the path and it encrypts it, and it makes it authenticated, which is the two things we need the most in DNS right now. So I really hope to get this online soon as well, but the DNS is fairly new, the RFC is fairly new, and the software isn't quite there yet, but hopefully soon. Okay, I'm finishing up. It's always hard to say what's going to happen about censorship in the future. I've been pretty pessimistic, and I've been right for most of the time. So probably the future will also offer new weird ideas about how to censor stuff online. It might not even happen in DNS anymore. It might be on IP level. It might be some deep packet inspection. We actually have an ISP in Denmark who has implemented the requirements for DNS censorship with deep packet inspection. So if you are on that ISP, which is called 3, and you say do a telnet to Google, one of google.com's DNS servers, and then write host:/grooveshark.com, then the TCP session is closed, because that deep packet inspection sees the host header, and it doesn't matter which IP address it goes to, because it inspects all traffic. This might become more common. It's a dangerous game to start playing to inspect traffic like this. At least when we're doing the censorship in DNS, it is really easy for people to circumvent, which is why I'm happy to make it even easier. Either way, my DNS servers will keep running as long as there's a need for them, and I fear that there will be for some considerable time into the future. I'm, like I said, looking for more nodes for the Anycast project because it'll greatly improve the performance and stability of the service. And like I said, it will also enable me to serve the users in South America and North America and Asia and Africa as well, much better than I can today. But since I'm running this on my own budget, I kind of need people to step up and offer to host one of these nodes. I cannot possibly go buy hosting in all these places, unfortunately. Okay, I'm done for now. If you have questions, then come find me here at Bornhack, or write me an email, or find me on IRC or Twitter, or one of the other million ways to contact me. You can read the blog where I've gone into much more detail about some of the political issues and some of the reasoning behind all the hate against Save the Children and stuff like that. And you can also get t-shirts and coffee mugs and stuff on the web shop to spread the word. I mean, spread the word, use the servers, do not use Google servers, do not give all your DNS lookups to Google or OpenDNS. Don't use a random IP address you got somewhere. Know who your DNS provider is. If you're not going to use me, then run your own server or use someone else you know. Don't just take it for granted that a DNS server will always respond truthfully. I have included a few links, among other things, the story about the German guy who got a hold of the leaked list and got the domains taken down in 24 hours or something. 30 minutes. And a couple of other things in this presentation, which will be available on the website after this. Okay, questions? Yeah? Sure. Hmm? Yes. Yes. Yes, I forgot to put that on the timeline. You're right. There was one in Turkey as well, with the same trademark. They're apparently very aggressive about using the word home for real estate, which is kind of what else would you use? I mean, it's just stupid. Right, of course. So what is the going rate for a censored domain these days? Oh, nice. There hasn't really been any activity towards trying to clean up the list. When for the years I've been trying to manage these censored servers, the number of domains has been almost constantly rising. And then at one point there was some debate about this, and they cleaned it up and removed a couple of thousand domains. And since then it's been rising as well. So it's been like a graph going like this, and then someone complained and it went like this, and now. So they're not cleaning up that much. And I fear that's one of the problems, because like with all legislation and stuff like that, it's really easy to implement, but nobody cares about removing it again. There should be some sort of expiry date or something on not just domain censorship, but probably all legislation. So when it gets times out, you have to actively introduce it again if you still want it, because as it is right now, nobody is cleaning up. Asbjørn?
There is a timeout on all the core orders. And there's one of the domains that have been blocked outside of the German list, which they have actually gotten removed again. And it turned out that in order to do that, they had to get the judge who signed the original court order to also sign the new one, clearing the old one. But also the way that it uses the court orders in a way to get at least legal to take the decision to block something, and not just do it because someone asked to do it. is incorrect in the way that the court order is just intended as a temporary thing until the real case. But there's never going to be a real court case around this. Everyone just takes the court order to temporarily suspend this as a final say.
There's room for one more question.
Yep.
So you seem quite excited about DNS over TLS.
Yes.
Authenticity side of things.
Yes.
As far as I'm aware, similar authenticity is in DNS script.
It is.
Is there you have some commentary over the security guarantees of the two DNS script?
No, I don't. I think DNS crypt might probably be using some fancier crypto, but I've like I said, I had some pretty bad experiences with it. So maybe I'm just like biased. You know, if you've had a like a rough weekend with some really crappy software, you're reluctant to go back and try again. But like I said, it has matured greatly, and I'm aware that TLS is not without its problems. So. So yeah, no, I'm not. I think I'm going to support both and see where it goes. Alex?
It's more of a remark to that. I think the difference is that one of them is now becoming a public certification, which means that it works with the entire path between DNS servers.
Yeah.
Whereas the other one is more of a link between you and the DNS server.
You're saying DNS over TLS is a more complete part of the...
Yeah, it's like a formal way of getting this through, but the other one seems to be more of a like some happens that are not together.
Yeah.
Can I go back to that slide so that you can see the all the details again?
Yeah, there's an RFC out, and it's pretty light reading, even for me, who's not a crypto guy. So, but it seems very clever. Cool. We're out of time, so but come find me at the bar later or something, and I'll be happy to discuss DNS and stuff.
Let's give Thomas
Yep.
a big hand.
Thank you.